Yes, all right. Wow, I mean, this theater alone and this stage alone, I feel like a rock star, but I will not start singing though. I promise you that. What I do is, I want to make a selfie first because, as always, I'm an engineer. And the problem is that my boss gives me time off to do this, and I want to prove that there are actually people in my room. Right? I mean, this is such a lovely and great room. So, wave. Awesome, thank you so much. So, I will not start singing, I promise you that, but I will start with a story. I mean, it's a story about my little cousin. I've got a little cousin, he's like 3 years old now, and every time I give him a new toy, he wants to do everything with that toy. He wants to eat with it. He wants to sleep with it. He wants to go to kindergarten with it. He wants to take it to the toilet, into the bathtub, whatever. He wants to do everything with that. Well, I told him it's not good to take your toy and put it into the shower, right? Because, well, if it's a stuffed animal, it will get a bit wet and a bit dirty. But that same idea of doing everything with something new, I found that developers do that as well. I mean, if we have some new code construction, some new technique, some new framework, we try to apply it everywhere. And we try to apply it just to make it work because, well, we like new shiny stuff. But that doesn't mean that the things we do and the things that we used are exactly for the problem we try to solve, right? I mean, if you see this guy over here, he's riding a motorcycle. And this way of riding a motorcycle can get you from A to B, which is no problem. Who drives a motorcycle over here? Hands? So a couple of you. I'm still wondering how this guy shifts gears. I mean, normally you do that with your foot, but riding it like this is possible, but probably not the way it works. And I know it's like that saying, right? If you have a hammer, everything looks like a nail. And maybe you work in teams, and I tend to work with smart teams. I hope that you work in a smart team as well, that people can think of them for themselves, and they can act for themselves. And you may have a product manager, and the product manager is like, get this done. And you might think, and you might say to him, well, if it looks stupid but it works, it is still stupid. Really. It doesn't mean if it works that it's not stupid, right? And again, you can say to that product owner, come on, you hired me because you hired a professional. Trust me, I'm an engineer. Yeah, that works with your product manager maybe, but not with your coworkers. If you work alone, you have all the right in the world to do that. Well, do you? First, let me introduce myself. My name is Brian. I work for a company called Sneak, and Sneak is a security company. We're not going to talk about security. I did that yesterday in a workshop. I'm co-lead for the Utrecht Java user group in the Netherlands, and something with Oracle Groundbreaker. Nothing much. But we are going to talk about functional programming. And that's the first thing. Functional programming in Java. Is that possible? Well, let's keep it to functional style of programming. I will be a little dogmatic in this talk, but I trust that you are smart people and you can think of yourself, and it will always be an edge case that I'm not right and your thing may be good enough. Fair, but I will go to a series of best practices, or actually a series of stuff I've seen in the last couple of years as being a consultant that actually made my eyes hurt. And I hope most of it you will say, I already knew that, and then I'm a happy man, because let's make this world a tiny little bit better. First of all, let's go to this first mistake you most of the time see. It's like doing too much in a single lambda. Well, who works with lambdas? Not all of you. Fair. Who works with Java 8? Who works with higher than Java 8? 9, 10, 11, 12, 13, whatever. All right, who's still on Java 7? 6? One hand in the top, really? No, I'm kidding. I cannot see the top even. Let's go to lambdas. But what are lambdas? Well, I'm very good at looking things up on the internet, Wikipedia, for instance. This is just Wikipedia. What is a lambda? Blah-de-blah, lambda expression. Well, basically, a lambda is something you can use inline as a parameter, or we can use it as something you give back from a function. So instead of only using values as parameters, we can now use functions, so behavior. So if we plot that to Java, because this is a lambda calculus in general, we can use lambdas like kind of anonymous inner functions, kind of, just to make it work. It needs to satisfy the functional interface, and you have basically roughly two ways of writing it, right? Input, arrow, output, input, and some kind of curly braces and a whole bunch of stuff. And there's the first problem. I mean, say we have this example. We have a very silly higher order function. And a higher order function is simply a function that takes a function as an argument. Well, this red higher order function doesn't do anything but print something and give the same thing back, or applies the function on the input. But for the matter of discussion, if you want to apply a function to a higher order function, you want to do that inline, and you can use a lambda for it, like we do that over here. So lambdas are very neat little things we can give to a function. Cool. But this is one way of writing a lambda. I think this is quite readable. Single line lambdas, very good, very nice, very concise, and readable. Because what we want to do is make code more readable, right? Well, if you look at a general code base for whatever big company, you find that people try to write lambdas like this. In a single function, trying to give that as a parameter to a function, to doing if, else, try, catch, switch, whatever statements in it. First of all, does it make your code more or less readable? I would say less. And there is something easy going on, and you might say, yes, I already know that. But just scan your code base for these curly braces in lambdas, if you do that. And there's a simple, easy solution. And it was introduced, I think, in 1995 in Java. It's called a method. Simply create a good method, and then we can use a method reference like we do here in the bottom line. You abstract it. If you really need to do more than one thing in a single function, you have to abstract it. And you should do it in a method that gives you a clear and cool and good name, and then you can do a method reference. This is the easy part, right? We all know this. Let's continue to the second one. The second one is returning a stream. And I'm not saying you should not return a stream, first of all. But you have to know a few things about streams. First of all, a stream is not a data type. Second important thing is a stream is not a data type. But okay, fair enough. You can tell me what it's not, but what is it? What is it? Tell me. Okay, what is a stream? A stream is actually a bit fuzzy. If we look from Java 7, 6, 5, and lower, and we now do streams, streams are a bit fuzzy. It's something that is derived from, for instance, a collection. You can use these streams. These streams are lazy by nature, and you can use these streams to create pipelines. But a stream is an intermediate result. And as I said, by default, it is lazy. They say you cannot transform data. You can transform data, but you cannot mutate data. Fair enough. But if we look into streams, we have two types of things, right? We've got a stream like we see above here, very neat, very, very easy. We can use higher order functions that are described on these streams, like map, filter, and we have, for instance here, collect. The map is part of that intermediate function. The intermediate functions. It gives you back a stream, stays lazy, it doesn't do anything until you terminate it with a terminal function. So we got intermediate and terminal functions. Fair enough. Well, there's one thing with a stream. You can only use a stream once. If I use a stream, and it's an intermediate function, and I declare it to a variable like I do on the second line over here, in my opinion, you're doing something wrong. Because why should you do that? You should only declare a variable, in my opinion, if you should use it twice or 3 times or 4 times. But a stream is a one-time use product. So for instance, the third line will go great, so the beer stream dot for each, perfect. But if I do it again, it will give me an exception. And that made me think, we cannot reuse streams. So should we go give a stream back as the result of a function? I would say be careful with returning a stream to a function, because it's not the same as returning a collection. A collection is static or is persistent in memory. A stream is something that's not. It's a one-time use intermediate thing. So, say we just call this function, and I call this getBeer function, and it returns me a stream. Do you know if that stream is already consumed or not? You don't. Can we check it? You don't. You're not able to check it. So should you return a stream? Yes and no. You can return a stream. You can perfectly return a stream if you're doing a private intermediate function to preserve that laziness. No problem at all. I'm cool with that. If you return a stream that is actually created at the point of calling it, list.stream, for instance, it's perfectly fine, because every time you call it, you give it a new stream. It's perfectly fine when you're returning a stream when your data set is gigantic, enormous. If it doesn't fit in memory, you've got a use case to return a stream. Because of the lazy evaluation, you cannot shift 1 million records perhaps in your memory. And then a stream is quite cool. But I would say, and I say this to students as well, for instance, if you start with this, take a collection as your default and then return that, because you can easily create a stream from that. Be aware that streams are not the same as data types, and by default, I think you should return a collection instead of a stream. All right. We're going into a little bit of debatable things. We're going to talk about mutable objects. Who likes mutable objects? Who hates mutable objects? So there are a lot of people or are still in their after-dinner dip and sleeping, or they have no opinion. No worries. I don't care. So if we go into functional programming and we look what is important in functional programming, there are a few things. You don't have to read it all. I've highlighted a few things. Changing state, mutable data, so avoiding changing state and mutable data, and it's declarative programming paradigm, and it's done with expressions. Okay, so functional programming is built on avoid changing state and mutable data. Fair enough. But if we go and quote one of my favorite scientists, Mr. Dr. Albert Einstein, he says, insanity is doing the same things over and over again and expecting different results. I think he didn't work with mutable data. If you would work with immutable data, that's true, but if you work with mutable data, if you do the same object over and over again to a function and it can change state, do you have the same result? No. If you're stateless, let's say it like that way, and you work with stateless objects, of course you have more memory footprint, but then you have to look at your whole program or at your whole service to see where is the top 10% if you want to increase these kind of things. But in general, I write code to make it maintainable, because I might be gone in 2 months or 3 months or hit by a truck, and my coworkers have to solve it. If you work with stateless data so that it doesn't change state, it's very easy to think about data. It's very easy to control it. It's very easy to reason about it. And I mean, simply what I would say is, like, asking a question shouldn't change the answer, right? If I ask you a question like, what is your favorite color? You might say it's blue. If I ask it again and you say it's red, you probably have been drinking, or I can mutate state. But asking a question shouldn't change the answer, nor should asking it twice. So immutable data, for instance, helps me making less moving parts. It's easier to reason about code, because I think that is the most important part. And we do not need to keep a mental mind map in our mind that say, okay, if I do this once, then the state is this, and then if I do it twice, it will be turned around, and then we have these things like I changed something here, and it will end up with failures over there. But let me go into code, because they say I cannot mutate, right? Let me just exit this one, share my screen on the other side, and over here. So, this is readable, right? For instance, I have a list of beers over here. You see? I create a stream out of it, and now I want to mutate it, like this. Say I have a beer, and I do something like beer.setName Devoxx Poland. Right? And it doesn't allow me to. But what is the problem it has here? No instance of type variable R exists so that void confirms to R. So the problem is the void. I can fix that. Let me go to the setter. And instead of void, I can create it like this, right? Ta-da! If I go here and I run it, and you see over here, I print the new list, and over here, just for reference, I print the old list. By running it, you will see that both the old and the new list, I did change the name. So you can mutate that data, but you shouldn't. I just told you why. Then I always get the question, but what should I do? Well, for instance, instead of setting a name, say something like with name, and change that function I had over here to something like this that doesn't give you that, but returns a new beer with the name I gave you and the old alcohol percentage. By running it now, going back to here and running it now, you will see, yes, oh demo gods, oh demo gods. You will see that the new list have the new beers, and the old list doesn't have that same change of name. And therefore we have new objects, but we can relate to this, and we can argue about this more easier than we do this, than if we do change state. So I would say, create new objects. That makes it far more easier than that. We can change state inside the stream. It is perfectly possible if we do these dirty tricks, but please don't. So, we went through all of this. I will skip this one. Overviewing. I will go to order of operations. And why I go to order of operations? Because people think that laziness, well, it solves everything. So I do not have to care about the order of operations. Well, that's not true. Just a little thing to keep you awake. Say I have a collection of beers, and every beer has brewer, and every brewer is from a country. Now I want the first 3 unique brewers' countries from the beer library and print it as a comma-separated string. The question I ask you now, is this correct? Who thinks this is correct? Who thinks this is wrong? Thank you. You're paying attention. And I talked about mistakes, right? So it's pretty obvious. The problem is here. We distinct on the beers, or we distinct on the brewers, not the brewers' countries. By simply changing it to here will give me the correct answer. Again, we are good programmers. You all write tests, right? You all have 100% test coverage. So you will find this out, no problem. This will give you an incorrect answer. Well, fine, we write tests, perfectly okay. But now we go to something like this, and I will show this one in practice. So, going to this class, I have an int stream over here. Oh, you see, oh, don't see it. Thank you. I thought it was changed. Maybe I can. Now you see it, right? Thank you so much for pointing that out. It would be silly to walk to see only a desert, right? So look at this stream. We create an int stream, we distinct on it, we limit it to 10, and we put a for each on it. Seems okay because the int stream is infinite. I limit it to 10, right? What could possibly go wrong? Well, let me show you. If I run this one, it will give me a 0 and a 1, and you see that it doesn't terminate. It still runs. If I go to my, you'll see it still runs on a single node or on a single thread. So what is the problem over here? The problem is that this one gives me a 0, a 1, a 0, a 1, a 1, a 0, a 1, etc. 1, Brian. What does the distinct do? We work with lazy evaluation, so this one keeps on going, right? The distinct gives me a 0 and a 1. Then the limit. First item is a 0. Second item is a 1. I have to limit to 10. So third item is, and it's stuck over here. And that's weird, because lazy evaluation should solve this, right? No. What you should have been doing was changing the order to first limit it to 10. And then distinct it, because at this point, we now have only 10 items in that stream. And then we can distinct easily, and it will run, and it will fail. Will not fail, it will stop and rerun, thank you. And it will actually execute and end. Can you imagine what will happen if I do the old code and do something like this? I mean, it's a bit chilly in this room. But now it's getting hot. If I look over here, you see it's not just only one thread. It occupies my whole machine. Who works on the cloud? Or serverless or that kind? Try to make this mistake on a cloud vendor and it pops up a new instance and a new instance and a new instance. It's not a denial of service, it's a denial of pocket money, I guess. So what you see is that you do not even see the intermediate results of 0 and 1 here. That's because, as you may know, if you use parallel, you will use the common fork joint thread pool, unless you give it its own thread pool, but just using it like this, you will use the common fork joint thread pool. And what does it do? Well, it says fork join. So it forks the part that can be parallel, and that would be the distinct and the limit. But it joins at a certain point. And the limit will be done basically at the point where you terminate. But it will never terminate. So it's still in that fork part. It will never go to that join part and will give you an intermediate result. With a single stream, you will have that. So the problem is two ways. First of all, we have to look at the order of operations that things simply terminate. And second of all, we shouldn't be using parallel like here and there. You should be using parallel only if you think your computation is that heavy that we need it to run in parallel. Because if you would run every single stream in parallel, you will occupy that fork joint thread pool, and you'll keep occupying it. And for a single stream, it maybe looks faster, but if you do it everywhere, you simply overpopulate that pool, or you have to do something about that. And that pool is not infinite, so eventually it will go slower. So keep that in mind. Going back to the slides. So, I told you this will run forever. This will run forever in all threads. And we should look at the order of operation. So first of all, should look closely at that, at the order to prevent incorrect results. But we all write tests, so I'm fine with that. And we should only use infinite streams when absolutely necessary. Because why should I use an infinite stream? Because of lazy evaluations, we can use infinite streams. And it's nice, it's cool. But is it actually useful? for your use case. If you want to use a stream or an in-stream like this, keep it within borders. If I use range and range closed, I know that my stream will not be infinite, because most of the time we probably use a stream to iterate a certain amount of times that we normally did in a for loop, or we want to iterate through a collection. So how useful would infinite streams be? I think 9 out of 10 times you probably go with a capped range. So you can use range closed, and from Java 9 and up, if you want to iterate over an in-stream, you could use a Boolean function as a predicate in between to make sure that it actually terminates. Be careful with that. Creating your own higher order functions. Who does that? A few. All right, cool. As I already told you, like creating a higher order function is just a new level of abstraction that you can use to make sure that you cannot only give values as a part of a function or a method. You can insert behavior now, which is pretty cool because we can abstract even more. But how does it look like? Well, as I said, higher order functions, we can use behavior as a parameter. And what we will use it for is to reduce boilerplate code or duplicate code, because, well, I think we all know that we do not want to repeat ourselves. This is a very silly example again. If we have two functions, and my first function was a log function that needs to log something in uppercase. It contains super interesting code, say 25 lines. Well, that makes my method a bit big, but just for the sake of argument. 25 lines before that red line and 25 lines below that red line. And now I do have to do the same thing, but lowercase. What do you see people do? Select, copy, paste, change that one line, YOLO. And that works. But you are repeating yourself. And we all know that copy pasting is the best way of programming, right? Because we do that every day from Stack Overflow. Well, you all already know that it's probably not so good because, well, copy pasting might give you some mistakes. And the only thing we want to change is one line. Actually, not even one line, only the last part of that red line, that 2 uppercase and 2 lowercase. Say I want to preserve this same API. I could do something like this. I could create a higher order function, the do-foo function. Yes, like any other programmer, I'm very good with names. But I can give it a string and a function that can be applied to a function. I can put that super interesting code in once on top, that other super interesting code at the bottom, keep it there, concise, on one place. If I need to change it, it's only in one place, and I can call that do-foo with a lambda. Well, this was a pretty good example, Brian. Did you ever use it in practice? Yes, we did. Before I worked at Sneak, I worked at one of the major web shops in Holland. It's basically the Amazon of the Netherlands. Well, Amazon is big, Netherlands is small, so, well, it was a quite small one. But still, we had a couple of million users, say 16, 17 million users. And the point is, we had our persistence layer was a Mongo cluster for the service we were working on. And that Mongo cluster consisted of a primary node and several secondary nodes. Because most of the things we needed to do were only read actions, we do only read from the secondary nodes, and we had to write on the primary nodes. So if I had to change a basket, because, well, sometimes I have to add a product to a basket, sometimes I have to empty a basket, sometimes I have to adapt a product, say for instance the color or the amount or whatever. So I had a couple of things that I could do on a basket within the domain layer. But if I needed to do that, I needed to do that on the primary node, because I needed to read from the primary node, not from the secondary node, and write to the primary, because that could be inconsistent. There's always a bit of lag between writing to the primary and copying it to the secondary, right? So for that instance, we created a template that we needed to read from the primary node, adapt it, and save it to the primary node. And in between that, we needed to run our rule engine. That rule engine, there were like a couple of thousand of rules that some things can apply, some things cannot apply. If I buy product A and product B, I get a discount, but not if I have product C in my basket, whatever. All these kinds of business rules that apply to that web shop. And I could do that for every function over and over again, read it from the primary, do that rule engine, and save it to the primary. But actually what I needed to do is only that edit part was the only thing that was different for every function. So what we did, and of course this is a bit smaller than the actual code, we created a function mutator by ID. And that mutator did read from the primary node. We gave it a consumer as one of the parameters. We used that consumer that was introduced on that thing. We run the rule engine, and we saved the basket. So what we could do now is every time to preserve the old API, when adding an item, removing an item, adapting an item, changing the color of an item, we kept the same API, but now called that higher order function with a consumer to make sure that the logic for reading and writing was in one place. This made our life a bit more easy than it was before. So now we can have a new layer of abstraction and leave the code in one place. Who likes optionals? Who hates optionals? There are always a few, right? So, people say that an optional is Java's implementation of the maybe monad. One people is scared of the word monad. He runs away. No, but seriously, it's not. If I look back at my days in the university, monad was a hideous thing. If the professor was talking about monads, everybody was a bit itchy, and then he said, well, a monad, I was doing Haskell, is a warm, fuzzy thing. Yeah, sure, whatever. But if you look at it from a Java point of view, what we're trying to do in a monad, and what we're trying to do in an optional in this case, we want to encapsulate certain behavior. In this case, the possibility that a value can be null. So let's consider it a wrapper, which it basically is. And what we're trying to achieve with that optional is to tell the user of your function, of your API, hey, dude, or hey, folks, this one function or this return thing can be empty. Do something about it. Because, well, no pointer exceptions are the worst thing ever, right? And instead of assuming that people will do that, now we explicitly give them that heads up. Well, you might think that optional now has two ways. It can be filled or it can be empty. Am I right? Or it can be null. So we still have the same problem. We live in an object-oriented world, so we can assign null to an optional. If we just agree all together over here that we will not ever do that, can we agree on that? Then this is no problem anymore. We just shove it under the carpet and never do this. So don't do this. And there's still people doing this, though. I really see it. But what you need to do now is, okay, I have an optional, and now I need to unpack it. So I need to get it. But that's the problem. Because if I just get it and I don't know if it's empty or not, it can give me an exception. So what do you see now? People say, okay, so I have to check if the optional is filled. Well, there is something that we can use like this. I could do an if statement, see if it's present or not, and then unpack it. Can somebody tell me how this code construction is any different from an ordinary null check? It is not. It is just solving the same thing, having the same burden of checking it, but now with a wrapper. Wow. But people are doing this. And what I think you should do is use the things that are declared on optionals, because if we use it in a more, say, functional way, or like optional is meant to use, we could do something like this. There are functions like if present, and then you can give it it's a higher order function that can be used, or we can use map, Or there are a couple of these things. By using this one, for instance, the map function will only be executed if the function, or if the optional is actually filled. So why not use it? Why doing that ugly if-else statement? Because we want to get rid of that. Okay, that's cool, but that map thing and that if is all right. But say we want to do something else. Say we say it's not there. How do we solve that one? Optionals. So, say I have an optional over here. And that optional, in this case, is filled with foo. Well, we can do three things. For instance, if I map a certain function on it, over here, if it's not there, it will throw an exception. Well, you probably all believe me in that, so I will not show this one. What I want to show is, say I want to do something else. I want to give it other behavior than when it's not there. I want to do something else. So, say I make this function, and I say run if empty. And it does not contain a string, and we say it's only run if optional is empty, and I will give it a default value like empty. And instead of returning it an exception, I will say, what can we do except a map? Well, or else seems fair. And I will call my run if empty function. And if I do a code review, 9 out of 10 people will say, this looks legit. I mean, my optional is filled, so map will be applied, so at the end, foo will print me the word foo in capitals, right? So I write a test on that, perfectly fine. But let's see what it does. It is, because at the end, we have foo. But in the middle, you see that both the thing run if exists, so this string is there, but also the run if empty is there, which I was first surprised of when I was using this, because normally if you have an if-else construction or something like that, it would have some sort of short-circuiting, and it's perhaps not what you expected. But it does, because or else is only meant to give you a default value and nothing more. Let's say you do this on your database. Say, okay, I want to see if a user exists. If it exists, I want to do something with that user. And if it doesn't exist, let's create it one. If you do this kind of work on that, then you probably have or duplications or a problem with your database administrator, because you have duplications. So what should you do? There's something else, and there is the so-called or else get. That needs a supplier. And let me just create a supplier out of this. If I do it like this, and I run it, you will see that only the map will be executed, and not the part in the or else. So although you might think that or else is a good way to do this, you have to be aware that there are small differences between or else and or else get. Or else is only there for giving it a value, for giving it a default value. Yes, show this, show this. So when you use the or else, please make sure that what's in the or else doesn't have any side effects, or that these side effects does not affect your state of your program or whatever, because it's only assigned to have you a default value. If you want to have alternative flow, new behavior, because of the optional is not there, please use the or else get. It looks like a slight difference, but it can be very impactful if you do not notice, and you see that like only in production. But again, your test right, so well. How many times do I have? 10 minutes. Let's go to, let's skip the next one. Yes, list optional, has to sound cool. Who knows what this is? And don't say a rocket. And don't say an explosion. Any idea? It's a rocket, yeah. No, yeah, it's a rocket. It's the Ariane 5 rocket. It's the rocket from the European Space Agency. And it was launched at June 4th, 1996. And there was a slight problem with it, because after launch it exploded, as you can see. What happened? Well, basically what they're trying to do is they try to convert a 64-bit floating point number to a 16-bit signed integer. And that was the velocity, the horizontal velocity of that rocket. Well, at the first part, the rocket wasn't that fast, but it started to increase and increase and increase. And then we had the point that we couldn't fit the 64-bit floating point into the 16-bit signed integer. And we had some sort of exception. And then it blew up. Moral of the story, we have to handle exceptions, because things might blow up. So say we have checked exceptions, and we want to use this in a lambda. Say this do something function has a checked exception, and I want to use it in a lambda like this. That is not possible, not in first sight. You cannot use it like this. How should you do this? Well, then again, I have to find something to not keep switching screens. So, say I'm going to my exception point. I have a function over here that randomly throws me an exception. Once in 5 times it would throw me, or 5 out of 10 times it throws me an exception. Fair enough. If I want to use this function over here in my library, it's not possible, because it says, well, you have an exception, you need to handle this. And then people say, well, IntelliJ can solve this for me. Right? If I do this, then it says surround with try catch. Runtime exception. Boom! Solved. But I think we just agreed in the first point that we shouldn't do try, catch, switch, whatever in a lambda. But you told me a trick, Brian. And we could do something like, where is it? Refactor. And I can extract, yeah, there is it. And then we want to extract it like, and we call it try something. Because again, I'm very good at naming. Now we can get rid of these ugly things. We can quit it over there. We can get rid of this one. Right. Yeah, return. Like this. And that works. If I run it, it compiles, and in this time it doesn't give me an exception. Lucky me. But the point is, you can do this. I mean, who did this before? Like shoving a exception that you had to check into a runtime exception and move on with your life. Just add, the rest of you are liars. Don't say you didn't use that ever. And for certain points, it may make sense. If you did, I mean, I'm not a fan of checked exceptions, but that's my personal opinion. And we can have that debate afterwards, because most of the time when it does have an exception at that point, it is the end of the world, because I already checked if that file exists or whatever. So it may be useful. But say you want to do it like this. I have to do it every single time for an exception? That's the worst thing ever. So what we can do is, let me revert this one. We can do something else. Say I want to do this. If you want to do this, I wouldn't recommend it to do it in a but say you want to do this, you can use your own functional interface. That is nice. So say I want to create that new interface, and I call this, well, checkfunc, because again, naming is hard, right? What I need to do, I need to implement the apply function, and I say throws exception. Okay, What I can do now, and I would, if you would do this, I would advise you to do this in some kind of util class or util file, whatever. And you can do something like this. I simply create a function called rep. And that rep returns me a function. And we're working with generic, so I have to do it like this. And as an argument, it takes my check function I just created. Cool. So what I need to do now is return it a function. And what I simply do is then I still need to catch that exception, but I do it once and for all over here. Like this. This I will abstract into a folder deep down below. Nobody will ever see it. And what I can do now is, instead of doing the try catch over here, doing it once and for all with my wrapper function. That is one possibility. I wouldn't recommend that. But if you're like lazy and say, runtime exceptions will never happen, good for you. But what is the problem if a runtime exception happens? Let me just run this one. And you see, yay, now it gives me a runtime exception. And it gives me a runtime exception after the first one. So I got 3 items in my list, and after the first one I had a problem. It stops immediately. It stops evaluating my stream. And if your stream is like 1 million items big, and it stops halfway, you already spent so much time. And do you want that? Probably not. Say we want to use the exceptional situation just as much as data as the good situation. So I will introduce the either type. It's not there in Java, but we can create it. It's just another wrapper function. And that either type does have or a left or a right. Not both, it's either a left or a right. So that can be, because it's generics, it can be an either type of string and integer. So the left will be a string and the right will be an integer. But we can use the same situation, for instance, for exception handling. And by default, in functional programming, we say the right is the right one and the left is, well, the not so right one, the wrong one in this case. And what we can do here, if we apply this stuff on your evaluation, it will end. Your stream will evaluate and will give you back a list of eithers. And now you can shift between, I want to use the left, or I want to take the left ones out, the wrong ones, and I only want to keep the right ones, or you can do whatever you want, but you're in control. And I think that is the most important part. So, say for instance, we go to the either type I implemented over here. It's either a left or a right, and I created a lift function. And as you can see, this lift function is pretty much the same as the wrapper I just wrote. Only if it's okay, I give it back a right, and if it's wrong, I give it back a left. If I use this one instead of the wrapper, and I said either dot lift, and I do this function, now I'm sure that this thing will evaluate from top to bottom. Only you see, at the first point I have an exception, the second and the third went okay. And now I can decide what I want, and not my runtime exception. I'm in control. But there's a problem with this, because only the exception is not maybe valuable. Maybe I want more. Say, if I want to retry it, I might want to use the original value. And either can handle anything. So we can also use the either type like this. Instead of only giving it the exception, I pair it up with the original value, and I can do whatever I want, because I do not want to rely on the message of my exception. So doing this in my exception code, so live with value, and I will publish all the code. Don't worry. You will see that if something goes wrong, I have both the exception and the original value. And now I'm back in control, and I can redo everything that's wrong, or I can just ignore it. That's up to you. All right, let me just finish up because my time is up. There is something as try, and that's known for the people in Scala, but it's also written in a library called Favor. It was used called Java slang. And the try is basically the same as the either, only it can hold an exception or a success. So it's pretty much stiffer. If you want to use the try, you can do it like that, and Favor has a lot of these kind of things as the lift functions. But if you want to do more, then you probably need to use the either if you want to hold the value for it. I would suggest that you take a look at Favor and see what kind of nifty things it has to use it in your functional programming. Although, if you only want to use it for exception handling, the code is here. It's just about 10 lines of code. And do you want to have yet another dependency in your code? Maybe not. So, handling exceptions, try to introduce something like either, which makes you in control, instead of the runtime exception. I want to finish up with, this is my name and my Twitter handle. If you have questions, I will be here all day, so come up. There is a link over here which holds the Java survey of 2019. We want to see how big the Java community is, what you use, what kind of Java thing you use. I urge you, and I want to ask you to fill it in, please. For now, I want to thank you for your attention. If you have questions, come up, see me, or Twitter me. Thank you.